Google Dorking, also known as Google hacking, is a powerful technique used by malicious actors to uncover information unintentionally made public on search engines. By mastering Google Dorking, we can reveal various sensitive files and information that shouldn't be publicly accessible. In this video, we will be building an AI agent to help us gather information about a target from Google. We will then deploy another agent to scrap websites and extract the juicy details. So let's get started. We will be constructing an AI agent that interacts with server.dev, an API service used for performing search queries on Google. Next, we will use the Scrape the Website tool provided by CrewAI to delve deep into the website and extract information. To set up CrewAI, we will first establish a virtual environment and install all the required libraries. The following command will be executed. First, we start by making a virtual environment to install all the essential libraries. We will start by installing the CrewAI framework. Then we will install the CrewAI tools. Also installing python.env library for importing the environment variables from .env file. After setting up all the requirements for CrewAI, we will start by generating the API keys. To connect with the server.dev API service, we need an API key. We will sign up on the server.dev website, navigate to the API key sections, and generate an API key. We will copy the API key and create a .env file where we will enter the following information. Similarly, we need an OpenAI API key for our AI agents to function. We will visit platform.openai.com, navigate to API keys, generate a new API key, and copy it just as we did with the server.dev tool API key and paste it in .env file. Now let's start coding. Our project consists of 3 separate files. Agent.py, this will handle the initialization of the AI agents. Tasks.py, here we will add the task that we want our AI agent to perform. Main.py, this is the main Python program file. So let's start by importing the essential libraries in Agent.py. From CrewAI, we import Agent, which is used to create AI agent with specific roles and capabilities. Then from CrewAI tools, we import server.dev tool and website search tool. From LangChain OpenAI, we import Chart OpenAI, which provides interfaces to OpenAI's language models, enabling the agents to process and generate text-based data on the model's capabilities. Then from .env, we import load.env module, a function that loads environment variable from a .env file. This is crucial for managing sensitive data like API keys without hard-coding them into the script. Now, let's set up a function to load environment variable from the .env file into the program, ensuring that any sensitive or configurable data used by the agents can be managed securely. We will initialize an instance of server.dev tool, which is assigned to the variable search_tool. Next, we will initialize the website search tool, which is assigned to scrap. Now, we will define our agents. First, we will start by defining the researcher agent. We will define the agent's role as an OSINT researcher specializing in gathering intelligence from the search engines. Next, we will set the goal to gather intelligence from search engines, and then we will keep the backstory as OSINT researcher, expert in performing Google Dorking and finding juicy information from the internet. Then set verbose to false as we want it to work silently. Allow delegation is set to true, enabling the agent to delegate tasks to other agents. In tools, we will assign search_tool as it will be gathering information from Google. In LLM, we will use Chat OpenAI and select the GPT 3.5 Turbo 0125 model, setting the temperature to 0.3. Temperature represents the level of randomness in the response generated by the model. The lower the temperature, the more deterministic the response, and higher the temperature, the more unpredictable the response. Similarly, we will define the web scraper agent and assign it a role, goal, and backstory. Here, the agent will be used for scrapping the discovered website by the researcher agent. In goal, we have stated that it will dig deep into the website and gather information. We will set verbose to true as we want to see which website it will be scrapping, and we will allow delegation to true. After these two agents, we will define our writer agent, which will present the output in a clean and efficient manner. We will keep its role as data organizer and set the goal to write about the gathered data in a clean format. We will write the backstory as expert in data organization, set verbose to true, and allow delegation so that it can connect with the other AI agents and collaborate with them to organize the data. We are done with Agent.py. Now let's define Tasks.py. In Tasks.py, we outline the task we wish to assign to the AI agent structured as follows. We import researcher, writer, and web scraper from agent, which consist of predefined agents that we have previously defined in Agent.py. Additionally, we import tasks from CrewAI, which facilitates the specification of the task for the agent. We begin by defining the task for the agents. Task 1 involves gathering data from a search engine. We initialize this task by describing it as conduct OSINT to identify and list all active subdomains of Tesla.com using Google Dorking techniques. The AI agent is expected to retrieve detailed, potentially sensitive information. The desired outcome for this task is list of active subdomain such as www.tesla.com, shop.tesla.com, etc. The agent will compile a list of subdomains of tesla.com by searching through Google. We will then assign this task to the researcher AI agent. Next, we define task 2, which involves web scraping. After the researcher agent identifies links on Google, the web scraper will delve into these websites to extract technologies used and the contact information from the discovered subdomains. The description for task 2 is scrape each subdomain provided by the researcher to extract detailed information about the technologies used and contact email addresses found on each site. The expected output is the detailed information from each subdomain, including technologies deployed like plugins and frameworks, and any contact email addresses. This task will be assigned to the web scraper agent. Finally, task 3 focuses on output writing. This task involves documenting and organizing the information about the subdomains collected in the previous task. The description will be documenting the information gathered from the previous task, focusing on the technologies and contact details for each subdomain of Tesla.com. The expected output is a structured document for each subdomain with sections for technologies used and contact email addresses. We will assign this task to writer agent. Now let's create Main.py. In Main.py, we start by importing load.env from .env and crew from CrewAI, which is used to manage a group of agents and their tasks as a single unit. From agent, we then import researcher, web scraper, writer. These are the three agents which are presumably defined elsewhere to perform specific roles. From task, we import task 1, task 2, task 3. We then define load.env to load environment variables, ensuring that all necessary configurations are in place before the script executes further operations. Next, we set up the crew. To do this, we define the crew as follows. Crew equals to crew. Then we define agents, which are researcher, writer, web scraper. Then we define tasks like task 1, task 2, task 3 and set verbose to 1. This enables detailed logging of the crew's operation, which helps in debugging and understanding the workflow execution. We then kick off the crew and assign it to the variable result. This will start the execution of the task assigned to the agents within the crew. The kickoff method triggered the agent to begin their task, and the output or result of these tasks are stored in the variable result. Print the result of the crew's task to the console. This could include the output from both the researcher and writer agents, depending on how their tasks are defined and what they return upon completion. Now, we will run this entire code and see what kind of output it produces. We can observe how properly each subdomain information is presented with proper format, and it has made our job much easier. Thank you for watching Artificial Security. Please subscribe and hit the bell icon to stay updated on our series. Drop your questions or suggestions in the comment sections below. Stay safe, stay informed, and continue pushing the boundaries of what's possible with AI in cybersecurity.